All right, lesson 2.4 is solving multi-step inequalities. This one's kind of going to be a shorter lesson because it's just a combination of what we've done so far. If you're comfortable with the one-step inequalities that we did last lesson of 2.2 and 2.3, and you're pretty comfortable with doing multi-step equations, you'll be perfectly fine doing this. So as per usual, here's the hardest one I can think of for this lesson, and I will come back at the end of it to just walk through it. Graph the inequality. And we have negative v minus 18 is less than negative 4 times quantity, or parentheses, v plus 3. So you can pause right now if you want to. 30 seconds. I think one of my students earlier today timed me. It took me 17 seconds, I think, or 13 seconds, one of the two. I started at the 30-second mark. That's how fast I was able to do it. So I could probably do faster. But anyway, just to go through some examples first of just multi-step inequalities. Here we have y over negative 6 plus 7 is less than 9. So I'll write over here to remind us PEMDAS. We're working reverse PEMDAS with addition, subtraction first, and then multiplication, division next. Here we're solving for y, which is on this side of the absolute value sign. So we're going to try to isolate y. What else is happening on this side? We have it's being divided by negative 6, and there's a plus 7. Addition, subtraction first, so we take care of the plus 7 first. And move this to the side real quick. Whoops. Move this to the side. So taking care of addition, subtraction first. We're going to be subtracting 7 from both sides. So those cancel out. Now we have y over negative 6 is less than 9 minus 7, 2. Now we take care of the division, multiplication. So we multiply both sides by negative 6. Those cancel out. Because we're multiplying by a negative, the inequality sign flips to the other side, other direction. We just have y on this side now. 2 times negative 6 is 12. So y equals negative 12. We want to graph it real quick. Realize the graph starts at negative 12. It is an open circle because it can't be equal to negative 12, and it is everything greater than negative 12. As another example, 2v minus 4 greater than or equal to 8. We have v on this side of the entire thing. It's being multiplied by 2. 2v, same thing as 2 times v, and there's a minus 4. Addition, subtraction first, so take care of the minus 4 first. So taking care of that, we add 4 to both sides to get rid of that. 2v left over here. 8 plus 4 is 12. Now take care of the times 2. So divide by 2. Those cancel out. V is greater than or equal to 6. If you want to graph that one real quick too. Starts at 6. Closed circle because it can be equal to 6. And everything greater than 6. Sorry for the slight abrupt cut, but from here, if you understand this, same thing as just multi-step equations combined with the special inequality rules of the symbols happening here. And if you're multiplying or dividing by a negative, the sign flips. So moving to our student journal, 2.4, page 46, we're just gonna do 1 through 5. So getting started on the first one, 3x minus 2 is less than 10. We have x right here. What's happening on this entire side? It's being multiplied by 3, and there's a minus 2. PEMDAS, take care of minus 2 first. We're going to add 2 to both sides. Those cancel out. 3x is left over. It's less than 10 plus 2, 12. I'm going to rewrite this over here. That's taken care of. Now we take care of the times 3. So divide both sides by 3. X is less than 4. want to graph that, I'm just going to choose here 4, open circle because it can't be equal to 4 and it's everything less than 4. Next one, 4a plus 8 greater than or equal to 0. I'm going to subtract 8 from both sides, addition, subtraction first. 4a greater than or equal to negative 8. Then I'm going to divide both sides by 4 to get a is greater than or equal to negative 2. And mark negative 2 is right here. Close circle because it can be equal to greater than negative 2. For this one, because whenever there's no symbol in front of, or there's no sign, no plus or minus in front of a number, you can always just assume there's an invisible plus there if you want to. So you know you have to subtract 2 from both sides. B over negative 3 less than or equal to 1. And then you're going to end up multiplying both sides by negative 3. Because we're multiplying by a negative, the sign flips. So those cancel out. Just b over here. 1 times negative 3 is negative 3. B is greater than or equal to negative 3. Close circle because it can be equal to greater than negative 3. Next one, negative c over 2 minus 6 is greater than negative 8. Just as a reminder, just notation-wise, negative c over 2 is the same thing as negative c over 2, which is the same thing as c over negative 2. As long as just one of them is negative, because if both of them are negative, that just turns into a positive, right? Negative divided by negative is a positive. So, that being said, right here I'm going to add 6 to both sides, get rid of that 6. Negative c over 2 greater than negative 2. I'm going to treat it like this one. So I'm going to multiply both sides by negative 2. Just go straight to a positive c. Because we multiplied by a negative, the sign flips. Negative 2 times negative 2 is 4. So c is less than 4. Open circle, less than 4. And this last one, if you remember the distributive property, I'm going to write this one out. 8 is less than or equal to negative 4 times d is negative 4d plus negative 4 times 1, which is negative 4. If I want to simplify this, adding a negative is the same thing as subtraction. So negative 4d minus 4. That's the same exact thing. And then we do the same kind of work from here. I'm going to add 4 to both sides. So that cancels out. Isolating d. 12 is less than or equal to negative 4d. Divide both sides by negative 4. Because I'm dividing by a negative, the sign flips. So it's just d over here. 12 divided by negative 4 is negative 3. I'm going to flip it around for math convention and also just ease of reading to make d slash what we're graphing on the number line to be on the left side. Starting at negative 3. Close circle, because it can be equal to everything less than negative 3, going towards the left. So, those are those examples. One example I forgot to go over. Oops. One example I forgot to go over. I accidentally flipped to the Chapter 2 quiz review. That's the next video. Is this. 1 is less than or equal to 8 plus m over 20. For this one, you might be thinking, okay, you said addition, subtraction first, so I'm going to subtract 8 from both sides first. I'm going to tell you, whenever you have a fraction that has multiple things on the top or multiple things on the bottom, like in this case, we have 2 different terms on the top. Terms are separated by a plus or a minus. So we have one term here, another term here. If we have more than one term on the top or the bottom, you can just treat it like there's an invisible parentheses here. And when do we deal with parentheses? Last in reverse PEMDAS. That's what the P stands for. So in this case, there's no actual addition or subtraction to do, just multiplication division. So we're going to multiply both sides by 20. Get rid of that one. 20 less than or equal to 8 plus m. And then you can just take it from here, right? Subtract 8 from both sides. That cancels out. 12 less than or equal to m. Same thing as m is greater than or equal to 12. And just to graph that real quick. Starts at 12, closed circle because it can be equal to and greater than 12. So there's that example. Some examples now of solving with variables on both sides. In this case, that means something like this. We have 6x minus 5 is less than 2x plus 11. Now we have x's on both sides of the inequality symbol. We have an x over here and another x over here. I would have shown you a little bit like something like this when we were first working with multi-step equations, and now I'm showing you again because now we're working with multi-step inequalities. If you remember me saying, at this point, because you need x on its own, just choose a side for x to be on. Doesn't really matter. It can be x equals that way or x equals this way. Just choose a side. I will tell you that if you can think a little bit ahead, you can make your life just a little bit easier. I'm just going to move this to the center. Like, let's say we're split into two different paths. Let's say over here we decide we want x on this side, so we have to get rid of the minus, or we have to get rid of the 2x. So we're subtracting 2x from both sides to get rid of it on that side. Alternatively, we could say, hey, actually I want the x on the right side instead, so I have to get rid of the 6x. Now, working with positive numbers is easier than working with negative numbers. So I'm going to ask myself, which way is going to get me a positive x, a positive variable? Is it 6 minus 2x, or is it 2 minus 6x? And in this case, if we do the math out, it's going to be the 6 minus 2x. And then we can just solve it from here. X is less than 4. If we did it the other way, it's still going to get us the same answer. Brings down to negative 5, less than negative 4x plus 11. Subtract 11 from both sides. Negative 5 minus 11, negative 16. Less than negative 4x. Divide both sides by negative 4. Because we're dividing by a negative, the sign flips. And just rewrite that around to be the same direction. We still get the same answer, but in my mind, this side is easier because we deal with a positive variable. If you can think enough ahead of like, okay, I have variables on both sides. I want to make my life easier. I want positive numbers. I have to subtract one of them from the other. Which one is going to get me a positive variable? In this case, it's going to be this one. So that's the way that I would prefer. Let's try a different example. 4 minus 2m is greater than 7 minus 3m. So in one case, we're adding 2m to both sides to get rid of this side. And in another case, we have adding 3m to both sides to get rid of the one on this side. So which one ends up getting us a positive m? Negative 2 plus 3 or negative 3 plus 2? In this case, it's going to be negative 2 plus 3. So that's the side I'm going to go with. Adding 3m to both sides, so that cancels out. 4, negative 2 plus 3 is 1, positive 1, and 1m is just m. So greater than 7, and then you continue to solve like normal. Oh, I didn't even graph this one. I'll graph this one real quick. So over here it ended up being m3, everything greater than 3. Open circle because it can't be equal to. If we did it the other direction, it still works. Let's see what happens. We decide to add 2m to both sides instead. So now we have 4 is greater than 7 minus m. negative 1m, and 1m is the same as m, so it's just like a negative m. Subtract 7 from both sides. We have negative 3 is greater than negative m. Okay, to turn negative into a positive, negative m is the same thing as negative 1 times m. We want to isolate the m, so we have to get rid of the negative 1 times. Get rid of negative 1 times, we divide by negative 1. Because we're dividing by a negative, the sign flips. Now it's just m over here. 3 divided by 1 is 3. A negative divided by negative is a positive, so I don't have to add anything there. And if I flip it around, just to have it on the same side, the left side, now we have the same answer as we do over here. Except you might notice in this case, we have the same steps of subtracting the two numbers, but now we have an extra step of just dividing by negative 1 such that we can have a positive m. So sometimes it also saves you a step if you can think far enough ahead to be able to make your life a little bit easier. But if not, that's okay. As you can tell, it doesn't really matter which way you do it. They will both give you the right answer and the same answer so long as you actually do it correctly, you know? Now, before I start doing some more practice problems, I want to show you 2 more inequalities. Inequalities with special solutions. Now, going off of the same branch as variables being on both sides of the equation, here we have something like this. We see we have some distributive property that we can take advantage of, so that's what we're going to do right now. I'm just going to expand it out. AB minus 3 greater than 4 times 2b. Just real quick, 4 times 2b. Same thing as 4 times 2 times b. 4 times 2, 8 times b is equal to 8b. So 4 times 2b is 8b plus 4 times 12, or 4 times 3, which is 12. And then from here, you might notice it doesn't really matter which side we decide for b to be on. Either way, we're going to be subtracting 8b from both sides. And those cancel out. So now what happens? Well, let's look at what's left. Negative 3 is greater than 12. Is this statement true? Is negative 3 greater than 12? No. So this one has no solution. Which also means no matter what numbers you put in as b, this entire inequality, it will never be true. No matter what numbers you put into b, so long as they're the same number. Never be true. If you want to graph this, here's the number line. That's it. There's no graph. There's nothing like this or anything. There's no number to start at because there's no solution. There's no numbers that b can be. Different situation. 2 times 5w minus 1 less than or equal to 7 plus 10w. Same situation, I'm going to expand this out. 2 times 5w, 10w, minus 2 times 1, 2, less than or equal to 7 plus 10w. Same exact thing that's happening right now. Regardless of which side we decide for w to be on, we have to subtract 10w from both sides. Both of those cancel out, so what's left? Negative 2 is less than or equal to 7. Is negative 2 less than or equal to 7? Well, it's not equal to, so is it less than? Yes, negative 2 is less than 7. This means that the solution is all real numbers. And if you want to graph this, there's a number line, and there's a graph. Just all the numbers. Just keeps running along the entire number line. Because this means that w can be any number, so long as they're the same number. And the entire inequality will be true. The result will still be true. So, just the 2 different situations, I suppose, of special solutions. One where there's no solution, one where there's all real numbers. If you end up working things out such that all of the variables just cancel out and disappear to equal 0, figure out, is what is left still true or not? If it's not true, then it's no solution. There are no numbers that the variable can be. If it is true, then it's all real numbers. The numbers that the variable can be is all of them. So, that being said, finish this off. The next page, page 47 now. We're just going to do 6 through 10. This time we only have to solve the inequality. There's no graphing involved. So let's just work through these. Here, number 6, 5 minus 2n is greater than 8 minus 4n. What I'm going to look at, because I have to get rid of one of them, which one is going to get me a positive n? Is it going to be adding 2n to both sides, or is it going to be adding 4n to both sides? Is it going to be negative 4 plus 2 or negative 2 plus 4? In this case, it's going to be negative 2 plus 4. So I'm going to go with adding 4n to both sides. Those cancel out. Negative 2 plus 4 is 2. So plus 2n greater than 8. And just do the work like normal from here. Write it up here real quick. Divide both sides by 2. Because 3 over 2 doesn't go in evenly, if it gives you a decimal in a calculator, just leave it as a fraction. So leave it as 3 over 2, and that's it. Now for this next one, you might notice there's 6h on both. So no matter which side, you're going to be subtracting 6h anyway. What's left? Negative 18 less than 1. Is negative 18 less than 1? Yes. So the solution is all real numbers. Next one, 3p plus 4 is greater than or equal to negative 4p plus 25. Now we have different amounts of p's on both sides. Which one is going to get us a positive p? We can either be subtracting 3 from both, or we can be adding 4 to both. In this case, I think 3 plus 4 is going to be better than negative 4 minus 3. So I'm going to be adding 4p to both sides. So that cancels out. 3 plus 4 is 7. P plus 4 greater than or equal to 25. And then we go from there. Subtracting 4. I'm just going to write it over here. Greater than or equal to 25 minus 4, which is 21. Divide by 7, both sides. P is greater than or equal to 3. Next one. 7j minus 4j plus 6 less than negative 2 plus 3j. Now on one side of the inequality symbol, I notice we have some like terms we can combine here of negative 7j and, or of positive 7j and negative 4j. So we combine them. 7 minus 4 is 3. So we have 3j plus 6 less than negative 2. Plus 3j. Then we have the same situations as before. We have an equal amount of variable on both sides. We have 3j on both sides. So subtracting 3j, what do we get left over? 6 is less than negative 2. Is 6 less than negative 2? No, that's not true. So there is no solution. And now this last one, got a bunch of distributive property here. We got 12 times 1/4 w. I will tell you, put this to the side right here. 12 times 1/4. The shortest way for me to explain this, the fastest way, is for me to tell you if you have a whole number multiplied by a fraction, it's the same thing as the whole number times the top number of the fraction. So this is the same as 12 times 1 all over 4, which is the same thing as 12 over 4. And 12 divided by 4 is 3. So if we come back over here, 12 times 1/4 w is 3w plus 12 times 3, 36, less than or equal to 3 times w, 3w minus 3 times 4, 12. Same situation, we have 3w on both sides, so it doesn't really matter which side we start subtracting from first, they're both going to cancel out. Now we have 36 less than or equal to negative 12. Is 36 less than or equal to negative 12? No. So this one is also no solution. Otherwise, that's really it. We have just putting all the pieces together of multi-step function or multi-step equations with inequalities. They work basically the exact same way. You want to do reverse PEMDAS, but with the special rules, like for example, if you multiply or divide by a negative number, the sign flips, something like that. Or nothing happens, you keep the same symbol. It does matter which direction that symbol is in. They mean different things. For solving for variables on both sides, if you can look ahead and try to think which one would give me an easier time, you can. Or if not, that's okay. Doesn't matter which way you do it, it will still get you the same answer so long as you do it right. And some special solutions that we saw here. One with no solution, where if both of the variables cancel out and what is left is false, it's no solution. But if both of the variables cancel out and what is left is true, then it's all real numbers. All numbers can go in there. So I will end this off with doing the hardest problem. Actually, just copy it and bring it all the way down here. Let's do it real quick. So we have negative v minus 18, less than, not less than or equal to, negative 4 times v is negative 4v, plus negative 4 times 3 is negative 12. I'm going to simplify this because adding a negative is the same thing as subtraction. Now I'm going to combine. I see that either way, either I'm going to be adding 1 to both sides to get rid of this, or I'm going to be adding 4 to both sides to get rid of this. So it's either going to be negative 1 plus 4 to get rid of this side, or it's going to be negative 4 plus 1 to get rid of this side. What's going to get me a positive v? Negative 1 plus 4, or negative 4 plus 1 is going to be negative 1 plus 4. So I'm going to add 4v to both sides. That cancels out. I get 3v minus 18 less than or equal to negative 12. Add 18 to both sides to get v alone on that side. Negative 12 plus 18 is 6. Now I divide by 3. V is less than or equal to 2. And it's graph, so there's a number line. Starts at 2, closed circle because it can be equal to, and everything less than 2. So there you go. That's basically it. Just putting all the pieces together. Nothing too fancy, nothing too special. If you have any questions, obviously if you have me, you can just ask me next time I see you. You can email me if you have it, shoot a message on Canvas, whatever, or leave a comment in the comment section below if you have a question. So I'll see you later.